day everyone, I am Nurfaraliyana Samburi and I am the presenter of this video. I am a master's student from Universiti Hussein on Malaysia. My research focuses on analysing voltage stability in electric power systems through photovoltaic integration. Now, let's break the title into three parts. Analysing voltage stability means that voltage is the main parameter analysed in this study. In electric power system means the network that generates and delivers electricity to consumers. To demonstrate this study, a standard IEEE test model will be applied to represent the network. Through photovoltaic integration means the study will show how voltage stability can be improved by integrating photovoltaic systems into the electric power network. New houses being built. More houses mean more electricity is needed, which puts pressure on the electric power system and can make voltage unstable. Unstable voltage can cause serious problems such as blackouts. Because of this, voltage must be kept stable, which is why voltage is the main parameter analysed in this study. As a solution, this research explores how connecting photovoltaic system to the electric power network can help maintain stable voltage. Rapid growth in electricity demand can cause voltage to drop to lower levels and become unstable. The electric power system becomes stressed and operates closer to its limit. Introducing a PV system helps to stabilize voltage level, but it is unclear how much improvement occurs before and after integration, especially under heavy electricity load. As a solution, place PV systems at critical locations to prevent blackouts and evaluate their impact on voltage stability to address the gap. The objective is to evaluate voltage stability by comparing the voltage condition before and after PV installation at critical locations. There are two novelties in this study. First, direct comparison of voltage stability before versus after PV integration. Second, strategic PV placement at critical locations instead of random installation. What is meaning of a critical location? It is a point in the IEEE test system where voltage is the lowest among all points and has the potential to cause blackouts. What is meaning of a strategic PV placement? It means placing solar panels at suitable sites such as critical locations to help keep the voltage stable. Random placement should be avoided to ensure the PV system is effective. This research aligned with the article from NET stating that the government aims to achieve 70% installed renewable energy by 2050. To achieve this country needs to speed up the use of renewable energy. That is why my research focused on applying solar PV to support this target. Additionally, my research supports 3 SDG, SDG 3, 11 and 13 by helping reducing the dependence on fossil fuel, maintain stable electricity for growing cities and communities, and support Malaysia in addressing climate change. Electricity providers in Malaysia such as TNB can use this study to keep electricity stable by installing solar PV at suitable locations. Solar PV developers can monitor voltage levels and select suitable sites to make solar panels effective and reliable for everyone. For the partner industry, this research was conducted in collaboration with Rekatronic. This is the diagram of IEEE test model used in this study. The diagram was converted into code and the test model was conducted using MATLAB software. This is the reference voltage range. The voltage must be within this range to be considered stable. Now, let's check the voltage values line by line. Lines 40 to 56 are identified as having voltage outside the acceptable range. Therefore, lines 40 to 56 are declared as critical locations, carrying a heavy load of 30.4 MW and 8.8 MW. To solve this voltage issue, connect the critical lines to photovoltaic systems. First observation, voltage at the critical lines is restored to the stable range after installing a 100 MW solar PV system. Second observation, the presence of solar PV allows the system to support higher electricity demand. Third observation, when the load reaches 60.8 MW and 17.6 MW, the voltage drops to 0.951 per unit but remains within the acceptable range, making this is a key finding of the study. The conclusion is, rather than just restoring voltage, the PV system allows the power system to handle higher electricity demand while keeping voltage stable. The key message is that strategic placement of PV at critical locations improves voltage stability and prevents potential blackouts. The research received 4 awards in 2025, including a gold, a second place, and a special award. So far, the research has 1 published paper, 2 accepted paper, and 1 still under review. That's all from me as the presenter. Thank you for watching this video.